In this CTF, we began with an Nmap scan. But for this vlog, we will begin by exploring the website for potential vulnerabilities. Our goal is to identify hidden files or directories that may provide access to sensitive functionality. Using tools like GoBuster or DirBuster, we can enumerate directories and find interesting endpoints such as the internal directory, which contains an upload page. This sets the stage for our next step, testing the upload functionality for potential exploitation. File upload vulnerability. In this task, we focus on exploiting the file upload functionality that we discovered earlier. We attempt to upload various file types and check which extensions are accepted and executed by the server. After testing multiple extensions like .php, .php5, and .phtml, we found that the server processes .phtml files. This gives us an opportunity to upload a crafted payload, ultimately allowing us to gain a reverse shell on the system. Gaining initial foothold. We now have the groundwork to gain an initial foothold on the server. After confirming the .phtml file upload works, we modify our payload to include a reverse shell. By executing the payload on the server, we establish a remote connection using a netcat listener, giving us access to the system as the low-privileged www-data user. This sets us up for further exploration and privilege escalation. But first, let's run a crafted script using Python to automate the testing of different file extensions to see which one the server accepts and processes. The reason behind the focus on .phtml is that during our initial testing, we discovered that .phtml was the only extension that the server accepted and executed as PHP code. This made the .phtml the key extension to target for exploitation. In this demonstration, I'm going to show how we gain a reverse shell on the target machine using a crafted payload uploaded via the web application. We previously identified that the server accepts and executes .phtml files, which allows us to inject malicious code. In the Python script, we looped through different file extensions to test what the server accepts. For .phtml, we've crafted a reverse shell payload. Here's how it works. So reverse underscore shell is equivalent to, we'll back out of that. Basically, we're going to run Python code, and there's a piece of PHP code in there. So I'll clarify that later. Okay, this payload uses PHP's exec function to run a shell command on the server. The command essentially tells the server to open a bash shell and redirect input and output to my attacker's IP address over a specific port. This establishes a reverse connection from the target machine back to my machine. Once the PHTML file is uploaded and triggered, the server executes this payload. On my attacker machine, I have a netcat listener running on the specified port. This listener is waiting to accept incoming connections. When the reverse shell executes, the target machine connects back to my machine, effectively giving me remote access to the server's shell. From here, I can run system commands, explore the server, and eventually escalate privileges to gain full control over the system. The key point of this attack is that it leverages a vulnerable file upload functionality, allowing us to inject and execute PHP code remotely, resulting in the reverse shell.
Test 1 2 3. This is going to be the final talk, and this is going to be a reminder for me. So this full command sequence that we see here, sometimes I'll have issues with it because if you try to copy sloppy and paste the whole thing in there, you're gonna have issues. So what we need to do, in this particular step, it's crucial to understand why running these commands separately is so important. Well, let me make sure I can find these commands in my GitHub. Go to Vulnerabilities University, and it's going to be down here. And the commands that I'm talking about, just bear with me. These right here, don't just copy them and paste them in this section right here. So in this step, it is crucial to understand why running these commands separately is so important. When we're exploring the system using systemctl, we're leveraging a vulnerability to the set user ID bit on /bin/bash. This allows us to execute the bash shell with root privileges. The process requires two distinct actions. First, we need to enable and run the malicious systemd service using /bin/systemctl enable --now $TF. This service changes the permissions of /bin/bash so it can be executed as root. If we combine this with another command, the shell may misinterpret the command and cause an error as we saw earlier. Well, as I saw earlier. Second, after the service runs successfully, we can invoke the root shell with /bin/bash-p. This -p flag ensures that the bash shell preserves the root privileges granted by the set user ID bit. So the key takeaway here is that by separating these commands, we ensure that each action completes successfully. This ensures the service runs first, and only then do we gain root access through privileged bash shell.